And the floor is yours, Mark.
Thanks, Oliver. I appreciate that. Hi, everybody. Welcome to our webinar today. We appreciate you taking your time out to share with us. We know that your time's valuable, and we're grateful that you're willing to take a few minutes out to hear some of our, at least hear about our new stuff. We've got some really good, exciting new things happening with Denso, and I think one of the key things for us is that they're all items that would help those of you who are either using the robot or those of you who are promoting our robot in the market. So I think these are tools that certainly help the end user in the end. And that's what I'm going to talk about today is Wincaps Plus. So you'll see on the screen there, we're talking about Wincaps Plus. I've listed down the components to Wincaps Plus. That's the robot viewer, 3D visual programming, optimal motion planner, home position guidance, and the palletizing builder. We'll share with you what each of those is. I'll try to do it in a little bit of a visually stimulating way, but I want to share this with you before I get into the next slide. I just want to reiterate, if you don't know who Denso is, Denso primarily is a car parts manufacturer. We're about a $50 billion a year sales organization in terms of car component sales. But one of the secrets to our automation, to our that capability being that large of a company is our automation. And we've got about 27,000 robots that we've built and developed for ourselves in our own factories. That goes across about 2,600 automated lines worldwide. So we want to be humble about it, but we also want to let people know that we are the largest user of small assembly robots. We're the largest producer of small assembly robots. And the reason that we're successful is because the robots are made to meet our production standards, which is high speed, precise automation, assembly, pick and place, whatever the task is. We've been able to create this tool for us that really, in the end, helps us with our bottom line. And that's not just smoke, it genuinely a key component to our success. So, we didn't just start with robots last night. We started back in 1967. So I'd say, I think we have some credibility in promoting our product, but this new stuff that we're going to share with now is just an add-on to really improve what we have is a mechanical component. We've really improved the software side, and I think in the end that's an advantage to end users. So let's not belabor that anymore, and let's just move on to the next slide. So I'm going to ask you this question. It's rhetorical. You don't need to answer it, but just do think about it. This is what it is. What single request do we hear from the robot user market? And we hear this from both experienced robot users, and we hear this from people who are new to the robot market. But typically what they want to know, or what they request really, is that the system is easy to use. I would say it in 2 words. It's got to be convenient and it's got to be simple. Some people might say everybody wants the easy button, but there is a little thought in some things. But we've got a tool that really does make things a little more simple. So this is our solution. We've come up with Wincaps Plus. It's a add-on to Wincaps 3, and I'm going to talk about that shortly here, but just let me point this out. It's an easy to use, visually appealing tool that brings the ease of use to life. You'll actually experience that. One of the key things with Wincaps Plus is the improvement in importing CAD files. That's easier than it has been in the past. And when we talk about this, we're really talking about pointing and clicking. That's what we're talking about in terms of programming. Point and click for programming, point, click and start with your location. You can actually grab the robot arm and move it to the position you want to teach and record as a position. So what we're really doing is introducing Wincaps Plus. What is it? It's a new product. It's coming out in July 2020, just a couple months away. And this is how it's defined officially. It's a software group combined with Wincaps 3 that allows the optimization of an application. It includes design, implementation, operation, and maintenance related to the project. I'm going to say it in another way shortly here, but that's kind of a snapshot of what we're trying to say. It's a software group combined with Wincaps 3. Makes things easier for you. So Wincaps 3 plus Wincaps Plus. On the left, you'll see that we're showing Wincaps 3. It's our offline programming software. That remains our offline programming software. It's supported by all of our controllers. We have a new RC9 controller that is available with our larger robots. That's the reason we have an RC9. We're now using and offering in the market larger, higher payload robots, which we have not in the past normally done that. In the past, we've stuck with our normal, traditional, small, high-speed, compact robots. That actually, they're not just small and high speed. The key with our robots is they carry a high payload in a small area, and that's important to us. But the addition of the new robots, the larger reach and the larger payloads required a change in the controller due to the size of the robots. So we've created the RC9. The RC7 is still in play. The RC8 is still in play. The RC8A is just a slight revision in the RC8. They're, for all intents and purposes, they're the same thing. So Wincaps 3 will work with all of those controllers and will continue even if we created I would imagine a RC10, but we're not there yet. I don't want to get ahead of myself. So Wincaps 3, offline programming software meant to manage programs and projects. It's meant to allow you to simulate your application at a simple form or a much more complex form in terms of creating and inserting CAD files around your robot. It allows parameter changes and things like that. But what we're really doing here today is talking about Wincaps Plus. That's the add-on to Wincaps 3. It's in addition to. So in a picture, it's Wincaps 3 plus Wincaps Plus. And I chuckle a little bit about that because it's just kind of funny to look at that and say it that way. But we're going to talk about Wincaps Plus. These are the 4 pieces to Wincaps Plus. The foundation of Wincaps Plus is Robot Viewer. You're going to that is a component to the other 4 softwares, if you will. It is the foundation for the optimal motion planner. It's the foundation for home position guidance. It's the foundation for 3D visual programming, and it's the foundation for Palletizing Builder. So let me restate what Wincaps Plus is. It's an add-on software to Wincaps 3. It's intended to be an easy-to-use tool. Whether you're an expert or a beginner, it's a time-saving component. It's confidence building for the beginner, and it's result-oriented in the end. What you're doing is utilizing the 3D visualization to allow greater visual awareness. And whether you're an expert or beginner, this is something that you can do. So you may not even know the language, but because of the way this has been created to use in a click and point fashion, you could program in our language through the 3D viewer. Actually, Robot Viewer, 3D Viewer is we're gonna talk about that shortly. Mixing those two, it's somewhat interchangeable, if you will. So here's for your mind's eye. This is kind of something to look at. You'll see that there's a yellow sphere at the end of the robot. You'll see the directional X, Y, and Z arrows, red, green, and blue. And this is just something to put in your mind's eye right now. So we're talking about Robot Viewer. I've really said this already. It's the foundation of the software. It really allows you to see what is happening in the application in terms of the robot's motion and the robot's path. Sometimes we're looking at the robot, we see it moving, it's actually on a path, but we're not seeing the path. In this Robot Viewer, and as we talk about 3D visualization, you're going to be able to see the path. You'll know where the robot is actually moving to. It's not going to be a guess. The key thing to this is that it's simple and it's easy, and hopefully we'll show you that as we go through here. Saying what I've just said, maybe in a little more technical terms, 3D Viewer is, as I've mentioned, shared with Wincaps Plus, but the key thing here is that the importation of the CAD files has really been improved and much easier to do. We work with the step files, IGS files, the STL files. We're going to add Paris solid files. They're not currently in the Wincaps Plus, but they will be. And really the goal here is to have easy management of the model structure. What we mean by that is you're going to have the robot in its place. You're going to import CAD files that build the cell around and with the robot. You're going to use these files. It's an easy to do process. So we take these files, step files, STL, IGS files, we convert them. After we convert them, we're going to see them on our screen viewer. We're going to see them in a dynamic image. This is another, just a visualization. You'll see the robot. It's got a couple of components around it. Let's talk about the 3D visual programming. Traditionally, these are common issues you see with programming. Really, there may be no experience at all with programming. The language may be foreign in terms of your experience with programming our robots. In our world, PAX script is our language. It's basically Visual Basic, if you will. But, you know, programs become busy. You start adding conditional statements, if, then, or else statements, things like that. And as you revise your programs, they become unclear. So we found a way to smooth this out and make things really easier to see with your mind. And these are the capabilities really that come with this 3D visual programming. You're literally going to be able to grasp the robot, locate it, and record the position. Just by grabbing it with your cursor, clicking, dragging it where you want it to be, you'll be able to see the coordinate you want it at, and then record that position. You're going to be able to program without even knowing anything about the language. The idea is it's intuitive. You know, you'll be able to see the flow control of the program. See, that's the part where things can get complicated, where you have robot motion. Robot motion's one component of what you're doing, and then the second component is your program flow, what to do when, right? So that sequencing is important. Being able to see that visually is, I think, incredibly helpful for those that are beginners. Those that are advanced, I think it just saves you so much time because you already see in your mind's eye what you're doing. It's just an improvement altogether. So what's going to happen is simple. You're going to be able to create a program through a visual process. If you look at the image that's on the screen right here, I got my cursor here, I think you can see it. This box right here in the upper right-hand corner are some of the click buttons that you would use to create the program. And if you look at the image where the robot is right below the programming box, you'll see that there are arrows giving direction to what the motion is for the robot. Also directional for your X, Y, and Z of the robot. Don't want to belabor that right now, but the point that I'm trying to make is you're going to be able to see where the robot's path is moving and to what location it's moving to. So once you've been able to create in 3D visual programming, all of that graphical information is created and converted into PAX script. So what you've basically done, as an example, if you look at the image on the screen there, the lower left-hand corner, you're going to see a basic program. It's not really that complicated, but that program is basically the result of pointing, clicking, and directing the robot where you want it to be. The next thing I think we really want to, the next software we want to highlight is the Optimal Motion Planner. This is really important just in terms of trying to reduce your cycle time, and we'll kind of go through, but here's an example where you're seeing an image and you can see 3 different paths, and on these paths you can see the cycle time. Well, obviously the 1.52 second cycle time is the one we would prefer. What's happened is the robot knows where its pick place is, it knows where its place location is, and it's calculated the path between those 2 positions to be optimal. Let me talk a little more about it in detail. So here are a couple of common issues in determining your path. Usually you're working in a tight or narrow environment. You're always worried about interference. You're trying to make your path optimal because you're trying to keep your cycle time down. But because that's a little more difficult, our cycle times tend to be a little higher than they actually need to be. And it has to do with that extra motion in a path that we might create. When we create these paths, we're doing it by eye, and it's difficult sometimes to imagine what that actual path and its trajectory should be. And actually, I would say it's probably impossible to create the optimal path by eye. So with the optimal motion planner, you're going to be able to fix your start point, your end point, and any beginner would be able to do this. Once you've picked those two positions, the robot's going to create the optimal path from start to finish. This lends itself to 3D bin picking. The key here in that case, and I talk about 3D bin picking in terms of being something that's considered the holy grail. Everybody wants to do it, and getting it to happen in a fast time frame without, agitating parts again is something we're all fighting for. But this software, in conjunction with your 3D vision, will allow you to eliminate interference. It's helpful in that activity. Let's talk a little more about the optimal motion planner. I think this is a pretty good image just to kind of see that pink bar, if you will, is standing vertically. It's in the robot's path. I'm going to show you a video to this so you can see it work. But the purpose is to create the fastest path, avoid interference. It's simple because you're just pointing and clicking. You're going from one place to the next to locate your positions. And if you have zero or a lot of experience, either way, you're going to be able to make this work for you. It's that simple. And I've mentioned this before, and 3D bin picking and this piece of software actually jointly work really well together. But really the point is this, the software is doing all the work. All you have to do is identify your pick and place locations. Let me show you a video. Should be able to play this for you here. So I might narrate through this a little bit. You can see here's the start. You're just going to get a start position here, and then you're going to click on the start point. It's pretty simple right there. You're going to confirm that and move the robot to your next position. You'll see by grabbing this here that you can rotate it and bring it to where you need it to sit. Record that endpoint, confirm that endpoint, and then you're going to create a move. Now, this is in 3D CAD, so the robot, because of the software around the robot and the controller are aware of that obstruction. Let's let this play out here. This is in real life here. It's basically going to run two programs, but you can see the motion in and then out again. And we'll run a second program, but you'll see where we insert this post. I'm going to run the program knowing that the post is there. We didn't create this path, the software did it. It's around it. It's got to get us out without hitting that post. Incredibly time saving because it's doing all the work. We're not trying to have to jog the robot around any of these objects and create a path teaching positions. All we're doing is using the CAD files to identify where all these items are located in the same cell. The next software that we want to talk about is home position guidance. I think probably, I would say in a word here, what we're really talking about is recovery. So let me just kind of run through the slide here. You'll see an image, but what you're really looking at in that image is paths, which I would say that were created to be optimal. So here's what happens in the home position guidance and why it really applies to recovery. You see, I've listed recovery second here. It's common to have a situation arise where you've got a robot inside of its working area, inside of a cell, and an e-stop might be triggered, or something's happened that's caused the robot to stop. We need to recover from that situation. Typically, it's tight spacing. There are tooling concerns. There are part concerns. Your tooling might be a very expensive piece of tooling. It may be just a vacuum cup. Your part might be a very expensive part. It might not be, but all those things relate to cost, right? What we're trying to do is protect our tooling, our part. We're trying to protect the robot. We're trying to protect the cell. And we are trying to be safe. I don't mean to list that last, but typically safety is the most important thing. And people who get involved in these situations, when they're really trying to deal with it and extract the robot from a tight position, it could be frustrating. So our solution is the home position guidance. It improves safety. It protects the robot. It protects the robot cell. It protects the tooling, protects the part, and it does help your sanity. In a phrase, I would explain home position guidance as one past trajectory. I said recovery before. This is probably an auto return or a just a simple recovery device. But this is how it's defined as a one past trajectory, meaning that once the robot has started from its begun at its start position and then entered its place position, it's assumed that since it's arrived at the final destination, it's gone down a safe path. So it makes sense that the robot can return home on that same path. Something important just to note about our controller, since we've got RC9 and RC8. In the RC9 series controller, the data is actually recorded on the controller for this once past trajectory, which allows you to activate this home guidance, home position guidance, or I would say auto recovery. I mean, auto return, if you want to call it that, might be a better way to describe this. But RC9, it's recorded on the controller. RC8, it's actually recorded with your computer. So you would have your RC8 or RC8A controller in conjunction with the software just recording this, and it records on the PC, and then the PC would be able to keep track of the path. So that's the difference between the RC8 and RC9 controllers with regard to this this newer software. Hopefully I didn't confuse you when I was saying that it was not coming out that clear. But RC9, it records. RC8, you need a computer to record the path and then run it back through the PC, from the PC to the controller. I think of the controller as a PC because basically it really is. Let's just show you a video. Now, show you the video. You're going to look at this and kind of say, well, what am I really looking at? What we're really trying to show is that these paths are being created by the software. That's what you're seeing. We're not teaching these positions. The software is creating the positions. The only thing we did is pick the locations of pick and place. Let's let this run through here, let you get the idea. This is the Kobata, by the way. The RC8A controller is inside the base of that robot. This is our collaborative robot. It's a smaller, lower payload type robot, but operates just as a traditional robot would. You guys get the idea here. It's just a matter of going to where it feels it needs to go, and it's not a feeling. It's actually using its data to determine where it's going. Right? Not that nebulous. I have some additional video I'll show you here shortly. We're going to go through the Palletizing Builder here shortly, but just let this run out here so you can somewhat see in your mind's eye again. I like that idea of the mind's eye. It allows you to really visualize something. In this case, you're watching the motion, but the motion is being created by the software. I think that's the most important thing to keep in mind. So let's jump to the Palletizing Builder. So with the release of the new large robots, the VM and the VL, we've created the Palletizing Builder as a complement to those robots. It's typical with larger robots that a simulation is created before the robots are installed or deployed, because it's not easy to move large robots around. Once you've put them in place, you're really leaving them there. With simulation, it cuts down a lot of time in terms of creating your pallet, but really it's the optimal way to do it because it allows you to do it without having to have the robot involved. So in this palletizing builder, we're really going to show you 3 basic steps to create a pallet. It's very simple. I'll show you a video on how it really works, but you really only need the box dimensions, the pallet size, and then the stacking configuration. You're going to import what the dimensions are, you're going to import what the pallet size is, and then you're going to define what stacking configuration you need. Just have a video here to run through this so you can see this. How's your Japanese? This is all visually done. This is the part of the ease of use. You know, somebody who's a beginner could absolutely do this. Somebody who's an expert can do this. Absolutely no problem. It's a couple of pieces of information, a couple of clicks, and you've created what you need to know for your pallet to program the robot for that palletizing routine. So in the end, it becomes a real time-saving component. In the past, you know, trying to create a pallet, even with a small robot, it's a difficult thing. But this is something for the larger scale robots, very convenient. We're picking the pallet size here. We're going to pick the configuration. What layout do you want your pallet to form? There's your pallet. Now, as I mentioned, this software is an add-on to Wincaps 3, right? So with Wincaps 3 and the conjunction of palletizing, you're going to be able to create a simulation and just insert the palletizing routine. Combine those 2 components. So this is an example, a rough example of a cell, and then the robot utilizing that pallet definition and allowing it to create its motion based on that. We'll let this play out here. Just bear with me for the radio silence here. We're just let this work through. It's not dropping the box. You're not seeing that, but you guys are smart enough. You get the ideas that the robot is just moving in the pallet routine that was created. That's the second layer there. You guys get that? Let's just share a little bit more. I want to let you see a little more visually with more towards the 3D viewer. I want to bring you back to that because that's a really key component here. The beauty is you can take a Wincaps project, you can import the CAD files easier, and you can create this graphic program through the process. But what you're going to see is something that looks like this. Let me just see if I can get this to work the right way. I might have to, you know, one of the techniques in these presentations is maybe to not be so perfect on the presentation, is to maybe jump around. I might just do that on you and show you the video. Let's see if it's not working right now. Hang with me, guys. I think I'm going to try something else here. Hang with me. I think you can still see my screen. Do this another way. You all see my, Oliver, you can see my screen, I think, right?
Yeah, I can see the PowerPoint.
Okay, good. I'm gonna use this we'll just shift here and play the video here. I just want you to see this visually. I think this is important. Sorry. 3D visual programming. So this is a potential image you would see with your Wincaps. It's going to rotate around here a little bit. You can see on the left the buttons with the graphic indicator. That's where we're going to use to program this system, program the robot specifically. If you can see closely enough, you'll see that there are pink arrows. They have a label next to them, which is move, which is a move command. The idea is to allow you to see the path and know that these events are happening in this application. And this is one of the key things to help somebody who's a beginner to see what's actually happening. You can move the robot, you can guide the robot with your cursor, you can record your positions just by clicking the button. But once you've done that, once you've established your positions, you can then see the motion. You can actually see the path. In the past, you would see the robot move, and you would assume it's going to move through a certain space. In this case, because of this tool, you're going to be able to see precisely where the robot's going to move through the space. I think that's really helpful for people trying to work in tight spaces, but really in their mind, being able to visually see how the robot's moving, what its next step is going to be, where does it go to, where does it turn. I think being able to see that's very helpful. And for you guys who are experts, it's just another feather in your cap. It's just another way to help you see things quickly. And I think you guys can see that that's a pretty visually stimulating piece, right? Definitely helpful in creating the program. And I think this graphically is pretty intriguing as well. All right, and then once you program it, this is what you're going to see. You're going to see this pack script. So that's probably the biggest piece advantage of WinCaps Plus is the simplicity in programming, and that's what we're trying to promote. That you can graphically create the program and convert it into an actual pack script language program. I think that's huge. Let me just take you a little further down the video and um, show you a little bit further. Just another visual image. This is what we showed before. It's a little bit longer, but it's about creating that optimal path. And actually, it's really about avoiding the obstruction. So all those CAD files exist. You teach the robot 2 locations. And because everything is inside the software, all the data is there, the robot's going to find its path. It's going to find its way around the obstruction. There's no jogging the robot in this case. You're not having to go left or right or up or down. You're literally grabbing a hold of the end of the arm and locating where you want to record the position. Very convenient. There's the obstruction. And again, you'll see the directionals, your X, Y, and Z with the red, blue, and green arrow directionals. X, Y, and Z of your tool. So you can see now the robot's path went around the obstruction. One more time here. I think you'd all agree that seeing this visually is something that's helpful. You may be thinking, well, it sounds like that's a lot of time to create all that. Really, actually, it's pretty simple. You import the CAD files, you locate them with reference to the robot, and you get the opportunity to begin pointing and clicking and recording and creating the program. It's that simple. So I'm not going to belabor any more with that. Let me just go ahead and I'm going to jump back into the whole presentation. You should still be able to see this. I think you can. So let me just recap real quick. July 2020, this is when Wincaps Plus is coming out. It's a software group that's combined with Wincaps 3. It's meant to allow you to optimize your application, anything from design, anything that's related to maintenance, implementation, operation at all is something that can help you. This is what it looks like. The 5 pieces, robot viewer being the foundation, Palletizing Builder, 3D visual programming, home position guidance, and optimal motion planner. These are additional resources. I'm going to wrap it up here and just to let you know that these are other entrances, if you will, to access us. We appreciate you spending your time with us, and we're grateful that you actually hopefully got something of some value out of that presentation. But really, we thank you for your time. We know it's valuable, and we're just grateful that you shared it with us. So I'm going to leave you with that. Wish you all the best. All stay healthy, and I'm just going to turn this over to Oliver again. So thanks all. You all take care.
Awesome. Thank you, Mark. It was very informative. Let me start to see if we have any questions here. All right, so we have just one question from Thomas. He asked if for the RC8 and RC8A, the Wincaps software needs to be running on a connected PC in order for home position guidance to work. Carlos stated that yes, the RC8, RC8A needs a PC to keep a control log to know how to backtrack. But for the RC9, it will be available as a standalone in the controller. What else here? Looks like not too many questions, so hopefully everybody understood. Mark's presentation is very, very informative. It looks like Wincaps Plus has lots of tools to make programming easier. It'll save a lot of headaches, that's for sure. And just very, very more efficient and optimal. That's terrific tools in the Wincaps Plus. On the right side on the chat, I again put the WebEx link for the webinars for the rest of May. So if you click on that link, it'll show you the list of webinars, and you can check all the check boxes and just register for the webinars in May. We'll have new webinars in June, I believe, but those will be updated in June, and we'll have that updated as well. But also on the right side, we have our DENSO Robotics website, which also has the webinars for an upcoming list. So click there for any updates. Let's see. Again, at the end, when we end the event, there's going to be a survey. It's 15 or 20 seconds. It'll just be a couple of radio buttons to see what you guys were interested in terms of robots, as well as what you guys want to learn in the future for a future webinar, so we can give you the content that you guys would like. As well, Mark is going to get in touch with everyone with their emails and follow up with the link to this webinar, the recorded link, and you can watch back on your own leisure just in case you missed something that Mark stated. So, all right, if there aren't any questions, I'm going to stop the recording, and thanks again, Mark. It was very, very informative.
Thank you, Oliver. I appreciate your help.
Yeah, no problem.